Hi, everybody. My name is Dario Presezzi. I'm the CEO and founder of Bioforcetech. So today I'm going to talk about being first and why is the worst and why it's not. But mostly I talk about 5 lessons learned from being the first one at producing a biochar from municipal sewage sludge. So when there's a big new challenge, and it was 2011 when we first started this, we started looking at biosolids and sewage sludge as like it was considered a waste that was not too much of a problem back then, but then problems started occurring. They started seeing there was a lot of contaminants in it and so on. So I had 2 options. I was like 22 years old, and I was looking at that problem. I don't know why I got fascinated by it. But in general, when there's a big new challenge, there's option 1, which you sit back there, relax, and have the other people make mistakes and start making new technology, and then one fails, and then the other one goes great and whatever. As soon as the market actually wants it, then you start making a business, and that's the smart decision. That's how you should do it. Or the option 2, where you keep convincing yourself that the problem needs to be solved, and you work on it. You work on it very, very hard, constantly. You make an insane amount of mistakes. And that is technically a terrible way of doing things. But as Alan Kay say, and I love Alan Kay, he says the only way to predict the future is to invent it. And so that's what we did. So the vision back then, again in 2011, was that sewage sludge is produced at wastewater treatment plants in cities. Right? Every city has a wastewater treatment plants. All the water goes there. It gets cleaned up. The water ends up in the river. And what it's left, it's something called sludges. And usually gets loaded into a truck pretty much 99% of the time, and then either go to landfill or incineration, or it gets used in land application as a fertilizer, which is technically a good thing, but now we're finding out more and more that that's really not a good thing at all. Because it's full of contaminants, PFAS, it's contaminating lands, and it's creating a lot of issues. So the idea is we just invent a technology, whatever it's going to be, place it directly at the wastewater treatment plants, treat it there, and make products out of it. We had no idea how to make it. There was no plan. So the first thing we did is we were like, okay, let's make energy out of it, and maybe a product will come out. And so we started with the mini gasifier, which was a terrible idea because biosolids is full of minerals. Those minerals solidify in the gasifier, and you find out that the whole thing it's stuck with this very hard material within a few hours. So then we designed a mini pyrolysis unit, which was good. It was producing some biochar out of it, which again back then, I'm putting this chart, I think 2011, maybe some people were talking about biochar, but that shows the amount of articles and like how many times it was mentioned back then. So we didn't even know that was the name. It was just a black thing coming out of the machine. And it was good, but the thing is, we needed a lot of fuel because we had to dry that biomass. And so there were still some issues. So we said, okay, we need to focus on drying then, because if we have all this biomass, but it's full of water, there's 80% of water, what do we do? How do we make it into this final product, or how do we make energy? And so we pivoted completely. So we're like, all right, we need to invent a dryer. That's because dryers are available in the market, but they use a ton of energy. More specifically, it's about 1 megawatt hour per ton of biosolids to even be able to get to the dry part. And then with the pyrolysis, you can make maybe, I don't know, 300 kilowatts. So it's completely nonsense. We're not making a sustainable solution like that. We're just trying to get rid of waste. So we created, so the first lesson learned is that there's a lot of water in sewage and other type of waste, okay, of this kind, organic waste. So we invented this machine. It took us a few years, but the concept is we have this big vessel. We load about 8 tons of material in it, and with the batch process, we optimize it so much the bacteria can heat up the biosolids on its own without using external heat to about 65 Celsius, which is decently hot. And that's enough for air when it flows to just evaporate water naturally. That let us save about 70% energy comparing to other systems out there. And so we found something that was good as the first step of the process. We now have, I mean, that, again, we pivoted and then went pretty good because we have more than 50 of these units running already and many, many more to come throughout Italy and United States. And it's for sure the most efficient dryer on the market. But the lessons that we learned here is that with new tech, so if you're inventing something new that didn't exist, like a biological drying system, it's never going to work the first time. So if you're thinking about an innovation, I mean, I'm sure it's not the first one to say that, but it hit us. We thought, we were young and naive, and we thought we're going to design it, it's going to work, we're going to sell many of these. Absolutely not. It took forever. So the first biodryer, for example, like it was very efficient, but it was super slow, so it didn't make sense financially. The second one was efficient and fast, but too much maintenance, and so on, and so on. All right, then we had a dryer. We could do pyrolysis. And so we're like, okay, now we're going to start building systems and install them. And we decided to start in California, which has the strictest air district in the country. So to be able to turn on something like this, you need permits, and permits took us 4 years. So you're a startup, you invented new tech, you already spent a lot of money, now you want to start making some money, and that slowed us down for 4 years. But still, that brought us to have the first pyrolysis of sewage sludge in the United States permitted, and it was permitted in San Francisco, which then allows us to distribute it around the country with ease. So the third lesson learned is that it's going to take much longer than anticipated. So any projects, I'm sure everybody knows it, if you ever worked on your house or built a new house, it usually takes double. It took us a little bit more than double, but like it took us about 10 years to get to a reality where we had an actual system running and producing and doing what it was supposed to. And then we got to the point where we started produce biochar, or we're about to produce biochar, and like whatever comes out of our system, it's nothing like the wood one that you've seen so far. We have a 30% carbon content, mineral content of many different minerals inside, so completely different. So the first option was we just throw it away in landfill, which was not what I worked so hard for. So we created a sub-brand called Our Carbon, which has the goal of developing high-performance carbon negative materials that are going to be used in different industries. That was the goal for it. We didn't really know if it was going to work, but we started because that's the goal. So first, we have a test unit in California. It's a tiny little unit, but replicates the full scale. We're doing already done hundreds of different types of biomasses, and we use it to study how the biochar looks like in many different residence time and so on. The unit, it's meant to replicate the big one, and we contract out from different municipalities or different waste producers this unit where we run tests, and then we can set it at very different residence time, very different temperatures, fully automated. We can produce just a few kilograms of biochar per day, but that's enough for us to do the tests that we need to. And Our Carbon focuses on many different industrial applications. The only thing we don't do is agriculture. There's so many of you working on agriculture, there's definitely no need of another one. And so we focus on energy storage, concrete, polymers, and inks. Our Carbon started in 2020, so it's been 5 years. We worked with hundreds of different industries. One of the main ones, so our biochar mostly goes into concrete because we found out because of the mineral content, our biochar actually improves concrete strength up to 30% load, and it's able to bring down the carbon footprint of concrete to 0 or negative. So we've done the first structural concrete building that's here of the United States and won the award from the Concrete Association of the United States. And yeah, so that's one of the applications, and it's working right out of the machine. So the way we produce it, it comes out as a granular, and this granular can go straight into concrete, replacing sand or aggregates, and immediately work with some water treatment, but it works. Then another way we do it, so we macronize it into a pigment that it's less than 5 micron in size. And we use it for screen printing inks. For example, my shirt right here, it's printed with it. We use it for, and then we use it in plastics as a replacement for carbon black. So the idea is we obviously study all the different type of plastics, how much load we can put in it, and all that kind of stuff. But the idea is to replace carbon black, which, you know, every black thing that you ever seen in your daily life, it's made with petrol that has been burned badly. We import it mostly from Asia and has a high cost. So we're doing a replacement for that. It works very great in some type of plastics comparing to wood biochar, because wood biochar is light and it's carbon and it doesn't like to bind with plastics too much, but ours does. And we do a lot of things with many companies. So here are some of the companies that we're working with in all these different type of applications. The demand is pretty good, and so our company pivoted again into a company that mostly make machineries, into a company that promotes and sells this type of replacement for carbon black and concrete additives. The fourth lesson learned is a lesson that everybody knows, that not all biochar are created equal. So the idea is that for special industrial applications, you require extreme precision, process consistency, and definitely feedstock consistency as well. So the unit that we worked on, it's a hybrid pyrolysis unit, which it heats up the reactor in 2 different stages. The first one uses syngas, combustion chamber, like many others. We collect that heat and then use it to heat up the first part of the reactor to give about 80% of the energy required to do the carbonization process. And then the second step, it's electric. So the electric side, again, it used only 20% of it, so it's not like a full electric pyrolysis, but it allows us to keep a very, very consistent temperature. So it's a compact modular design. We test it and wire it directly at the factory, so that pretty much when it comes in about 3 days is ready to go. You can do a set points just like the mini unit between 5 and 60 minutes. Set points of temperature between 500 C and 680. And we have a precision of about plus minus 1 degree Celsius. So every time you change the parameter, you can change the quality of your biochar, or the characteristics, let's say, not the quality, of what you want to come out. Here's just some pictures of arriving at a site in Italy when we're going to be doing the first testing. And this is the last lesson learned. So one of the most important things that I've ever discovered, and I know, again, it's supposed to be a known thing, but if the machine is not easy to operate for an operator, or it's not running smoothly, that creates a giant paper brick. And we've seen that with many technologies out there in the past. And so if any of you it's a manufacturer, please make sure that the machine is very easy to operate and maintain for operators. And so we focused on that a lot. And we believe this is the solution. All right, thank you so much.